Hello, in this video we're going to be learning about while statements. There are two forms of a while statement, a do while and a while. So this video assumes you have already loaded Visual Studio and can program in Visual Studio. But first I'd like to go over what we call some pseudocode. Basically it's English-like statements and they can be translated later to regular C++ code. Okay, the while statement, let's go over that. So taking a real world example, let's say someone spilled a box of toothpicks on the floor. Okay, while some condition, here's a condition here, while this condition is true, I'm going to do everything in the while statement. Now see how I've indented these two statements? That helps in readability because you know we're in a while statement when they're indented, because the while starts on the leftmost side and then we indent one tab and we have the commands part of the while. It might be helpful for us at this point to put it on our curly braces. That's the way it looks in C++. So while there are toothpicks on the floor and I haven't picked up 10 yet, pick up a toothpick and increment the number of toothpicks to make sure I've only picked up 10. So basically, here's a condition, which is a compound condition. We have the left side here and the right side over here. So I'm going to pick up 10 toothpicks. Now let's contrast that with a do while. With a do while statement, we have the same thing, but it looks a little different, right? We're going to do something and then we are going to check on a condition. Okay? This is the same condition that I had in the above example. Okay? So let's say someone spilled a bunch of toothpicks on the floor. I'm going to pick up a toothpick and then I'm going to increment the number of toothpicks I picked up, which if we look up here, we do the same thing. I pick up a toothpick, then I increment the number of toothpicks I picked up. But the difference between this do while loop and the while loop above, I am guaranteed to execute this at least once. Okay? So this will be executed at least once. This might never be executed. If there are no toothpicks on the floor, I might never execute this statement. If there are no toothpicks on the floor, I will still look for a toothpick in this case. The difference between a while statement and a do while statement. The do while statement will execute at least one time. That's guaranteed. The while statement might not be executed at all. So remember that difference. I would like to go over one more thing before we go to the coding. So let's say we want to create a chessboard. Now if you played chess or checkers, you know the board is 8 rows by 8 columns. So there's a total of 64 cells. Let's call each square a cell. So we're going to begin creating our cells by setting up a start value and an end value. Our start value is 0, our end value is 7. So that's not 7 cells, that's 8 cells because we're starting at 0 and going to 7. Now we have an outer loop which is really consisting of rows, and we have an inner loop which will consist of columns. I've just put in some braces so we can see a little more clearly these while loops. But our outer loop will start at 0. See, I've said I to start, so I starts at 0. When we enter the loop, we set j to 0, and the inner loop will begin. So j will loop from 0 to 7. So I is 0, j is 0, then j is incremented, j is 1. So we are always incrementing our j value until we have created all 8 of the columns. When j is the end value, 8 or 7, when j is greater than 7, we will exit this loop. So we create a row, and then we increment our column values. Then we increment our row value. So now we're at row 1. We reset our j value. Then we're going to enter our inner loop. So we're going to start with row 1, column 0, row 1, column 1, row 1, column 2, and so forth until we've done all 8 of the columns. And this will just continue until we've done all of the columns for each row, creating an 8 by 8 chessboard. Now let's go to our C++ and do some practical examples. We're not going to do anything complicated in these while loops. As you can see, I've started with my basic shell for my C program. In this case, I need to create a variable. So I will create a variable called I. Normally variables are multiple characters, but traditionally I, j, and k have been considered counters. That goes way back to when I was programming. So if you are creating just a simple counter, it is okay to use I, j, or k, and that's what I'm going to be using here. So I have a counter, and I'm going to write my while loop. While I is less than 10, I'm going to do something. Here I'll put in my braces, and notice how it's indenting automatically for me. That's part of the readability. I just want to output what value I is. One thing that gets people a lot is forgetting to put an increment value here. If I forgot to put I, increment I would create what's known as an infinite loop. Let's do that now so you can see that. I'm compiling the program. Okay, there's another problem. Let's abort. In this case, the compiler found out that I did not initialize I. So I has gobbledygook in it right now. Let's initialize I. And because I never increment I here, I'm just going to be in an infinite loop. Let's try that again. See? It's just continuing to go and go and go forever. Just like the Energizer Bunny. Let's break out of this. Somewhere I should be able to stop debugging or stop running. Let's just try closing the window. That'll got it. So now I'll increment I in here. I, and there's a few ways you can increment I. I'll do it the most standard way right now. Set I equal to I plus 1. And I'll show you a couple variations in subsequent examples. Okay, let's run this now. So we started at 0. We're going to go, what's our end value? What's the last I value that will be displayed? If you said 9, you are correct. Because once I equals 10, we're going to exit this loop. So we're going to start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I is incremented to 10. Well, 10 is no longer less than 10. We will exit the loop. Let's run this and verify that case. So we go from 0 to 9. Now that was easy, right? So that is the basic while loop. Now let's change this to a do while loop. For a do while, it looks similar, but I'm just going to move the condition down here. So in this case, I am doing something while I is less than 10. So remember the do while, I'm going to execute this loop and then check my condition. Okay, so let's run this, and really, what results do you expect? Let's see. We get the same results as we got from the while loop, but let's modify this a little. Let's say I happen to be 10 in the do while loop. We're going to execute at least one time, right? So let's run this. And of course, I executed this at least one time, right? You saw that, right? Okay, count equals 10. But in the while loop, let's change this back to a while loop. I will put this back up here. And run. I get no output. So that is the difference between a while loop and a do while loop. Now I want to show you a compound statement while loop. Okay, this is just to show you that the while loop can get complicated if you so choose. I'm going to create a Boolean value. I'm going to call it don't stop. And let me reset this back to 0. While I is less than 15 and don't stop, I'm going to do something. I'm going to print out I, but I want the user to enter a number. Enter a number. Cn, I'm just going to call that num right now. Let's create a variable. Int num. Let's change this Now I'm going to change this so it looks a little different. So what I'm doing here, I'm going to say what count we're on. I'm going to go to 15. I'm going to ask for 15 numbers. Let's say if num is 2 or num is 3 or num is 5 or num is 7. Let's do one more. Or num equals 11. So if someone enters one of the first 5 prime numbers, I'm going to set don't stop to false. And I don't want to forget my curly braces here. So I'm going to put a curly brace here. Now what this means I'm going to do is if I enter one of the first 5 prime numbers, I'm going to exit the loop based on don't stop. Otherwise, I'm going to collect 15 integers. So if I just enter 3 integers and enter one of the primes here, I will exit the loop at that time. Otherwise, I'm going to continue looping until I get 15 integers from the user. Let's start this and see how it works. And this says I got a problem. So let's look at this. What was the problem? Uninitialized. I'm forgetting to initialize my variables. That's not a good thing, to forget to initialize variables. I'm going to set that to true. So while I don't want to stop, I'm going to be doing this loop. So let's run again. Enter a number. 4. Okay. So my first number I entered was 4, 6, 8, 9. Now let's enter in a prime number. 3. So once I hit a prime number, once I entered a prime number, it stopped. So I'm going to do this while loop while the left hand side is true and the right hand side is true. Once either of these conditions are false, I'm going to exit the loop. That's why in this case I exited the loop once I hit 3. Otherwise I would continue to ask for the user to enter in integers until I've collected 15 integers. For the last example, let's do the nested while loop. So with the nested while, I need I and j. I don't need these two. While, and I'm going to set some constants. Constant int start equals 0. Const int end equals 0. Remember, use constants when you can, when it makes sense to use a constant. These are never going to change. Except I'm going to set my end value to 7. So the outer loop will represent the rows and the inner loop will represent the columns. While I is less than end, I'm going to do something. We are setting j equal to 0. And I have my inner loop here, which is my columns. Let's add a comment here. While j is less than end, we're going to do something. Cout cell and I will increment my j value. Why did it indent here? These are things you should pay attention to. The reason why we indented here is that the IDE is expecting something, meaning I didn't completely finish my last statement. What did I forget? If you look, you can see I forgot my semicolon here. Now I'm going to increment my j value, and here's an alternate way to increment j. J plus equals 1. So this is just a shortcut to say j equals j plus 1. So the variable on the left is equal to that same variable plus the value on the right. You could have divide by, you could have multiply, you could have mod, you could have whatever you want here right before the equal sign. And then we must increment our I value. Can't forget to increment I. So here is another alternate way to increment. Just I plus plus. That means increment I. Okay, so here is a nested while statement. The outer while, remember, is the rows go through the outer while loop goes through the rows and the inner while loop goes through the columns. So let's see this work. I did not put an endl here. Let's put an endl here. Otherwise, things will get kind of bunched up. Now, if we print one line in the inner loop here, do you have a guess as to how many lines we're going to print out completely when we go through this program? Any guesses? Stop this if you want to try and figure it out yourself. Otherwise, if you said 64, you are correct, because we're going from 0 to 7 in the outer loop, and we're going from 0 to 7 on the inner loop. So that's 8 times 8. Let's run this. It only went up to 6. Why did it go up to 6? Did I... End is... Sorry, I made a mistake there. It shouldn't be 6. It should be 8. We're going to be creating 8 rows and 8 columns. So now if we run, we can see we go from the first row, which is row 0, column 0 through 7. The second row, which is row 1, column 1 to column 7, and so forth until we get to cell 7-7, creating our 8x8 chessboard. This concludes the video on while statements.